Welcome students to the next chapter called as matrices. A very simple chapter with a high weightage, sometimes with 6 marks and sometimes with 8 marks. Okay, it is an arrangement of elements in rows and columns. Arrangement of elements. Elements means generally we can say numbers. In start we can say it numbers, but variables also can come elements. But they are arranged in rows and columns. Okay, let's understand everything with an example in front of you. Matrix. A is equal to a matrix is given. This is called as a matrix. Can you all see the square brackets? Yeah, they are the square brackets. Round brackets will not do. Curly brackets will not do. We should have square brackets. 6, 9, 7, 3, 3, 2, 5, 2. These are called as elements. Can you all see this 6, 9, 7? Horizontally arranged. The horizontal arrangements are called as rows. So I will say 6, 9, 7 is my first row. 3, 2, 5 is my second row. 1, 3, 2 is my third row. Similarly, vertical arrangements are called as columns. 6, 3, 1 is my first column. 9, 2, 3 is my second column. And 7, 5, 2 is my third column. And it's compulsory, students. Here it's very important, order of matrix. In every sum, in every numerical, you will be thinking, you will be pondering on order of matrix. What is order of matrix? Order is always R cross C. Don't say as multiply, it is R cross C. R is number of rows or total number of rows, and C is total number of columns. As we can see in the above example, we have total 3 rows and total 3 columns, so 3 into 3. But the important concept here is always row ka number comes first and then column ka number comes. Okay, and it's not necessary that always they both will be same. We can have 2 rows and 3 columns. We can have 1 row and 3 columns. Okay, so this is 3 into 3 or 3 cross 3. Don't say 3 multiplied by 3. But in your submind, if you multiply also, so you'll get the answer as 9. So this will be like you have 9 elements in this matrix. Here comes the name of the matrix. It's a rule that name of a matrix should always be a capital letter. It can be any alphabet, but it should be a capital letter. Okay, now let's proceed to some other concepts which are more interesting. Now, in the above matrix, I have an element C. 6. I have an element 6. Now, if I want to reach up till this element 6, I want to give the address to one of my friend. Okay, hey dude, go till 6. I want. So he will ask me, sir, give me the address. So what is the address of reaching up till this 6? Now please see the cursor carefully, all of you. Please see the cursor. Okay, let's highlight. I'm highlighting it. Can I say okay here? In this column 6 belongs to, and can I say in this row 6 belongs to? So if at all I want to guide anybody that reach up till 6, what address should I give him or her? I should say go in the first row and first column, then only you can locate 6. So students, address of any element is written in the subscript. Can you see here 1 1? Don't call it as 11. The first number denotes row का number और दूसरा second वाला number denotes column का number. So 6 belongs to first row. Always row का number comes first and first column. So I have here 1 1. And why this small a? Because matrix are denoted by capital A. So individual elements inside the matrix are denoted by small alphabets. If at all I would have written capital B here, so I would have written small b here. A11 matlab first row first column. Don't say 11. First row first column is 6. Now all of you, now let's go on for some other one. 9. Students, now I'm not highlighting. You'd say, can I say 9 belongs to once again the first row? And which column does 9 belongs to? 9 belongs to the second column. To the second column. So like it's like the first row and second column. So first row, second column, 1, 2. Similarly, I'll ask you one more thing. Tell me about this 3. This wala 3. This 3. I'll highlight this 3. This 3. Tell me which row it belongs to. It belongs to the third row. And which column? It belongs to the second column. So what will be the address of this 3? This element 3, the address will be small a subscript 3, 2. Okay, beautiful. Now let's proceed further. Okay, from here we can say actual chapter starts. Row matrix. Students, there is no rocket science here. Row matrix means any matrix which has only one row. Yeah, that's it. It's so simple. 6, 3, 5. It's just a one single row. So it is called as row matrix. But if you see the cursor. 6 is in the first column. 3 is in the second column. 5 is in the third column. So we have 3 columns. So order is 1 cross 3 or 1 into 3. Next, column matrix. Oh, great. Column matrix means any matrix which has only one column. Only one column. 6, 3, 5 is one column. But can I say I have 3 rows now? 6 is in the first row, 3 in the second row, 5 in the third row. So order will be 3 cross 1. Next comes the concept of rectangular matrix. On the screen, rectangular matrix. Listen the definition, please. Listen the definition clearly. If at all you see, if at all anytime you see that the order is unequal, that means number of rows and number of columns are unequal. Number of rows or number of columns are unequal. They are not same. Then always the matrix becomes rectangular matrix. Simple, because only opposite sides when are equal, they are called, it is called as a rectangle. So that's the reason. Here I have 2 rows and 3 columns. 2 rows and 3 columns. So this is a rectangular matrix. Come on, once again. Whenever order is unequal, that means that number of rows are unequal to number of columns. दोनों equal नहीं है, तो वो क्या होता है? Rectangular matrix. Now students, can you tell me the definition of a square matrix? Yes, I have here on the screen some examples of square matrix. This is the square matrix. See here, 2, 2, 2 rows, 2 columns. See here, 3, 3, 3 rows, 3 columns. So what will be the definition of square matrix? When number of rows and number of columns are equal. तो कोई भी अंदर एलिमेंट्स कुछ भी होने दो. When number of rows and number of columns are equal, we call it as square matrix. Once again here, 3, 3. So it is a square matrix. Diagonal matrix. Another concept. Diagonal matrix. Whenever a diagonal is formed, either starting like this, either starting from top left to right bottom, or starting from right top right to left bottom. If diagonal is formed, then it is called as diagonal matrix. See the technical definition. In this, non-diagonal elements are 0. So here this and this are 0. So it's very obvious, whenever these 2 elements are 0, then only this diagonal can be easily categorized, or these 2 elements are 0. So when non-diagonal elements are 0, then we have a diagonal. So either the diagonal can be in this fashion or this fashion. This type of matrix are called as diagonal matrix. Students, we'll be learning 3 different types of matrices or matrix based on the common category of diagonal matrix. So understand this definition. Whenever non-diagonal elements are 0 and a diagonal is formed either in this fashion or this fashion, that matrix is called as a diagonal matrix. Now let's proceed further. Scalar matrix. I have another thing of scalar matrix on the screen. Now pay attention, scalar matrix. You will be amazed with the first line. It is a diagonal matrix. Oh, it is a diagonal matrix. Just now we studied diagonal matrix, that there will be a diagonal formed. Can you see this? A diagonal is formed. See this? Same diagonal, diagonal. So can I say every scalar matrix is a diagonal matrix? But what's the difference? Difference is here. But difference is all diagonal elements are equal. So अगर diagonal elements equal हो गए, दोनों 6 या दोनों 9 या any number, अगर diagonal elements internally equal है, so of course matrix is a diagonal matrix, and to be more specific, it becomes scalar matrix. Hope you understood the difference. So whenever a diagonal in a diagonal matrix, if elements of diagonals are equal, they are called as a scalar matrix. Next, identity matrix. Now you will be more amazed by looking at the first line. It is a scalar matrix. Now what is a scalar matrix? It is a diagonal matrix in which diagonal elements are equal. So now इसमें क्या अलग है? Having all diagonal elements as 1, compulsorily 1. See this, can you see this diagonal? 1, 1, this is a diagonal matrix. Of course, a scalar matrix because diagonal elements are equal, but it should be 1. So we call it as identity matrix or unit matrix. We can say not if all the years, every alternate years you will have something or the other in the board's paper dealing with the identity matrix, which is also called as unit matrix. Unit means 1 and identity also means 1. So that's why we call it as, there are 2 names for this matrix, identity matrix or unit matrix. This is the matrix of order 2 rows 2 columns. This is the matrix of order 3 rows and 3 columns. See this one, this is the diagonal. Can you see this diagonal? All the elements are equal, so it's a scalar matrix, but all the elements are 1, so it is an identity matrix. Great. Last concept in dealing with types of matrix. On the screen, okay, transpose of a matrix. Transpose. What does this word transpose means? Just remember this keyword, interchanging. Transpose means interchanging whom? Rows and columns. अगर rows and columns को we interchange, we get transpose of a matrix. So what does it means? Rows becomes columns, columns becomes rows. That's it. Let's take an example. It's very self-explanatory. Let's take an example down. I have a matrix A. Can I say 6, 3, 2 is its first row? 7, 1 minus 5 is its second row. Now we are interchanging. So 6, 3, 2, which was the first row, now it becomes the first column. 6, 3, 2. 7, 1 minus 5, which was the second row, now it becomes the second column. 7, 1 minus 5. So earlier order was 2 rows 3 columns, now it becomes 3 rows 2 columns. And very important, transpose matrix is denoted by either a dash at the power or a small t. So a dash or a raised to small t. Great. Students, now instead of explaining you the basic addition and subtraction concept in matrices, I'll take in a simple example, and this example will motivate you all. In 2018, this sum was there for 3 marks, and what you have to do, you have to apply the difficult concept of addition, which you are applying since second and third standard. So this is the chapter, very simple. Question is there in front of you. Find the value of x and y. I have two unknowns, x and y. See, can you see x here? See, this is x, see my cursor, this is x in first matrix. Y, where is y? Oh, y also is here. Can you see this cursor? Okay, now comes the solution. Before starting with the solution, please understand, listen this carefully. Whenever you need to find any unknown values within a matrix, the unknown values can be obtained only by comparing two matrices. So when we can compare only when there should be only one matrix on the right hand side and only one matrix at the left hand side. Here I have only one matrix on the right hand side. See this, my cursor. But on left hand side I can see here two matrices. So first I will club them together by using this plus operation. So when I reach a case that on left hand side also I have one matrix and right hand side also I have one matrix, then I can easily compare and I'll get the answer. Let's start with the new solution. Solution is there in front of you, students. Solution. I just copied the question here as it is. Now students, I will keep this right hand side matrix intact. I will not change this because I told you I need to have one matrix at right and one matrix at left. I'll just copy this down. See this. And here if you see on the left hand side, this matrix, see the cursor, 6 minus 7 4 5. I copied this as it is same here down. So what I have changed, I have actually changed this matrix. 2 multiplied by x is 2x, 2 multiplied by 7 is 14, 2 multiplied by 9 is 18, 2 multiplied by y minus 5. So be careful. 2 into y is 2y and 2 into minus 5 is minus 10. So 2y minus 10. Only this matrix has been changed. Now what will be the next step? Next step will be, I will be clubbing this two matrix together into one matrix by using what? By using the plus operator. Students, just a normal addition. And remember, right hand side I have only one matrix. I'll copy same as it is. See this, same. Everything I'm doing on left hand side. Okay, let's do it, all of you orally. 2x plus 6 I wrote here, 2x plus 6. Once again, 14 plus minus 7. But because I have minus 7, so I'm straight away writing minus 7. So 14 minus 7 here. Next, 18 plus 4. See here. 2y minus 10. Pay attention here. 2y minus 10 plus 5. 2y minus 10 plus 5. So next, after that, I reached this step. 2x plus 6. I wrote it here as it is same. 2x plus 6. 14 minus 7. It is 7. 18 plus 4. It is 22. 2y minus 10 plus 5. I can solve this minus 10 and plus 5. Minus 10 plus 5 is minus 5. So 2y minus 5. And on the right hand side, I'm once again here. Now students, here comes the dreams day. See this. Can you see this red box? This is the ultimate step. I achieved my goal over here. I have only one matrix on left hand side and only one matrix on right hand side. So now I can compare. I can compare two matrices only when both of them has same number of rows and columns. So now 2x plus 6 is equal to this first element 10. Of course, now second one 7 is equal to 7, but no need to compare here. What we will do with that? 22, of course it's equal to 22, but no need to compare. Here comes the scene. 2y minus 5 will be compared with the 15. Compared means it will be stated as equal to. By which law? See this law. It's compulsory to write this statement by equality of matrices. So 2x plus 6 is 10. I wrote this and I call it as equation 1. And 2y minus 5 is nothing but 15. So I is equal to 15. So I'll call it as equation number 2. So now just solving this, you all can pause the video and solve it. You can get the value of x. 2x plus 6 I have on the screen. 2x plus 6 equals to 10. 6 goes there and x ka value is 2. From second equation, I have something on the board that 2y minus 5 is 15. Minus 5 goes there, so becomes plus 5. And here we get 10. So we got the values of x and y. Hope you understood. It was so simple. Just merely we are using plus operation in this. Last sum of this part, 2013 sum. Once again, why I selected this sum? Apparently looking at this sum, see the question, 3 matrices. So we can say this is very tough sum, but students, it's a plus minus sum, which we did in second or third standard. Matrix A is given, matrix B is given, matrix C is given. Find matrix X. Okay, I need to find a new matrix X such that, and here comes the key step. They have told us such that means it's the given part. It's something given. What is the such that? That A plus 2x is equal to 2b plus c. This is the given part. Using this, we need to proceed further. See, I have copied this here as it is. So let's start with the solution now. Starting with the solution. Students, here I've copied the given part, and we all know that x is the thing which we need to find. So we are doing this thing since our childhood, that jo bhi find karna hota hai, let's keep that thing alone on one side. So here x is multiplied with 2. Okay, fine. So I'll keep this 2x here only. I'll send this a on right hand side. So 2b plus c, it becomes minus a. Okay. Now 2x, I'll keep it as 2x only. Don't forget, students, this x is a matrix. It's not just a variable. Okay. So 2x, I'll keep as it is 2 only. This 2, I'll copy this 2. See the cursor, please. 2 will be copied as 2. And at the place of this b, I copied the matrix B, which was given in the question. Similarly, at the place of this C, I copied the matrix C. I kept very well this minus sign in between. At the place of A, I copied this matrix A. Next step on the screen. Can I say this 2x will be remaining as 2x only? This 2, which is there, multiplied with this entire matrix. Can I say this 2 will be multiplied with each one of them? 2 into minus 3, minus 6, 2 into 2, 4, 2 into 4, 8, 2 into 0, 0. That's it. After that, we are done with the previous step and we are on this step. Now this step is so simple, but here also some students make mistake. Understand this carefully. For you, you must be feeling, sir, what is so important? But I don't know why students make mistakes here. See, I'm just highlighting the first elements. Okay. See this matrix. Minus 6 I wrote here. It was plus in between. So I'll write plus 4 here. Here it is minus and here it is 2. So I'll write minus 2 here. Understood? Now see this. Here it will be for second element 4 plus 0 minus of minus 6. So it will become 4 plus 0 and minus of minus 6 becomes plus 6. So 4 plus 0 plus 6. Similarly, 8, I wrote 8 here plus 0. So I wrote 0 plus 0 here. Minus 2. So I wrote minus 2 here. And just we need to solve it. So when we solve this, minus 6 plus 4 minus 2, it is minus 4. 4 plus 0 plus 6 is 10 and so on. But is this a final answer? No, this is not a final answer. Why this is not a final answer? Because students, we need to find only the value of x. But I have 2x. I don't need this 2 here. So can I say this 2 is multiplied with this x? So when this 2 will come on this side of equal to sign, it will be divided. Of course, 2 here on left hand side is multiplied. So when it comes on right hand side, it will be divided. So this is the step. 2 comes here and becomes half. And this is the same matrix. Now, students, this half will be multiplied with each and every element. This half will be multiplied with each and every element. So half into minus 4 becomes minus 4 upon 2. Similarly, half into 10 becomes 10 upon 2. half into 6 becomes 6 upon 2, half into 2 becomes 2 upon 2. So now minus 4 upon 2 is minus 2, 10 upon 2 is 5, 6 upon 2 is 3, 2 upon 2 is 1. This is the answer of matrix X. Hope students you understood the concepts. Thank you.